Today we are going to talk about hydrocarbons, naming and drawing hydrocarbons and alkyl groups in terms of regents exam. So before we get started, please make sure to download the organic chemistry handout that is posted on Google Classroom, and also make sure to keep your reference table in front of you as we go through the questions. In this question, we were asked to identify the number of electrons shared between carbon atoms in a molecule of vinyl chloride. It's always a good idea to read the last sentence first from a question. If you're not satisfied, you can read the whole thing. But since I know that I have to figure out the number of electrons that are shared between carbon atoms for vinyl chloride, I have to figure out where that is from the question. And it seems like this compound is vinyl chloride, and then I see two carbons, and in between those two carbons we have a double bond. So I know that based on covalent bonding concept, I know that each bond represents, so each bond represents two shared electrons. Since I have two bonds between these two carbons, so I have C double bond C, that means the number of electrons that will be shared is 4. So they're sharing 4 electrons, or you can also write 2 pairs of electrons shared in between those two carbons. And that would be our final answer for this question. Next question. This is a chain question where the questions are related to each other. We have to draw the structural formula for the product from equation 1. And we have to figure out where the product is. In a chemical reaction, you will have an arrow. Sometimes it's a double-headed arrow. Sometimes it's a single-headed arrow. So if it's a single-headed arrow, whatever you have on your left side, they're known as reactants. Whatever you have on your right side, they're known as product. We're drawing something from the product side, meaning we're drawing something from our right side. And in this case, we have to draw this thing. And the name of this compound is 1,2-dichloroethane. First, what I'm going to do is I'm going to focus on the parent chain. I always focus on the last name first. That's what we have been doing since day 1 for my class. Eth represents 2 carbon. Ane represents single bond. Again, eth means you have 2 carbon. Ane means all of them are saturated single bond. And then I will complete rest of the bonds for carbon. So each carbon must have 4 bonds. I already have a single bond in between these two carbons, so I'm going to draw rest of the 3 bonds for each carbon. Now, once you're done with the last part first, then you can look at the first name. And in this case, we have 1-2, meaning in our first carbon, whichever that is, and in our second carbon, we have something. We have an additional group. So if you're counting from left to right or right to left, in this case, it doesn't matter because we only have 2 carbons, so we can decide either one. But in my first and second carbon, I have something called chloro. And chloro sounds like chlorine. That means in my first carbon, I have a chlorine, and in my second carbon, I have another chlorine. You can draw it anywhere you want at this point. Again, at this point, do not worry about where you should be drawing as long as you have one chlorine for each carbon, since the name is 1, 2 dash dichloroethane. So I can draw it anywhere I want. I can draw it here, I can draw it there, it doesn't matter. What do I do with the rest? I have to add hydrogens for the empty bonds. And this is the structure for 1, 2 dichloroethane, where I have a chlorine in my first carbon and a chlorine in my second carbon, or vice versa. For this question, we have to identify the class of organic compound to which the product of equation 1 belongs. So if we are looking at equation 1 and we're looking at the product, it's 1 2 1, 2 dichloroethane. So we need to look at our reference table R. And if we're looking at reference table R, since we have chlorine in our compound, in our product, the functional group is going to be halide. So anytime we have fluorine, chlorine, bromine, or iodine, the functional group is going to be halide. And you can identify this by using reference table R. So the answer for this question, you can have multiple answers for your Regents exam. So you can write halide, you can write halocarbons, you can write alkyl halide. All of these answers are correct. The next question is asking you to explain in terms of chemical bonds why the hydrocarbon in equation 1 is unsaturated. So if you're looking at equation 1, the hydrocarbon that we have, and again hydrocarbon means hydrogens and carbons only. So in this case we have carbon double bond carbon. They're asking you why, explain in terms of chemical bond why the hydrocarbon in equation 1 is unsaturated. All you can say is there is a carbon double bond with another carbon in this molecule. So we can simply just write that there is a C double bond C bond in each molecule. Students might write ethane is classified as an unsaturated hydrocarbon because each molecule contains a double bond, right? There are other students who might be able to write ethane molecule contains a multiple carbon-carbon bond. All of these answers are valid during your Regents exam. For the next question, they gave us a table, they gave us some information, and again, my advice to you is always read the last part first. So here we need to draw a structural formula for 3-ethyl hexane. As I said before, always and always read the last part first. This is something we have been doing in our class since day 1. So I'm going to draw hexane first. So I drew 6 carbons in a single straight line. Hex means 6 carbon, ane means all of them are bonded with single bond, right? So keep that in mind. Saturated, single bond. Always draw the last part first. Now I have to decide my third carbon. So if I'm counting from left to right, this is my third carbon. If I'm counting from right to left, this would be my third carbon. So you get to decide which one is your third carbon before you add ethyl group. And what does ethyl means? Ethyl means you have to draw 2 additional carbon in that parent chain of hexane. So I drew 2 more additional carbon in my third carbon from left to right, and that would represent ethyl group eth means 2, and this 3, the number 3, represents the location of the additional alkyl group. Remember, it doesn't mean you have to draw 3 carbon. It means in the third carbon from the parent chain, you're drawing an additional 2 carbon, which represents ethyl group. So I drew the hydrogens, and I also color coded for you so that you can see the ethyl group. And again, ethyl group means you have 2 additional carbon in the parent chain, and these are the 2 additional carbon in the parent chain. And the parent chain is this, which is hexane. We have 6 carbon in the parent chain, and then in the third carbon from those 6, we have an additional ethyl group, and that's the structure. Remember, when you're drawing ethyl or propyl or any other group, always draw them in a single straight line. Do not break them apart, because if you break them apart for this case and draw 1 carbon at the top, 1 carbon at the bottom, then it is no longer an ethyl group. Instead, it would be dimethyl group. So in this case, they're asking you state the temperature range for fraction collected that contains octane molecules. The question sounds very complex, even though it's not. All you have to do is focus on octane, and you have to ask yourself, what does octane means? Octane means, if you look at reference table P, you'll realize that octane means having 8 carbons in total. So what is the temperature range for fraction, right? Even I don't know unless the table is given to us. So here we were given a table that listed temperature range and number of carbons. So if I know that I have 8 carbons in the octane, which falls under the category of 5-12, obviously 8 is in between them, and therefore the temperature range would be 40 to 200 degrees Celsius. So your correct answer would be anywhere between 40 degrees Celsius and to 200 degrees Celsius, and that would be the correct answer. For this question, it's slightly tricky, where they're asking you to identify the number of carbon in an atom. They're telling you it's an alkane with 22 hydrogen. So you need to use the information about hydrogen to figure out the number of carbons. So this is where we have to look at reference table Q and use the general formula to identify the number of carbons. So based on our reference table, the general formula of alkane is CnH2n plus 2. That means 2n plus 2 adds up to 22. So we have to solve for n. So we can figure out 2n equals 20. So if we solve for n, that means we have to divide both sides by 2. And if we divide both sides by 2, we'll get n equals 10. And that is the number of carbon. So if we have 22 hydrogens, if this number 2n plus 2 adds up to 22, then the total number of carbon that we are going to have in an alkane is 10. And that's your final answer. So we covered some of the regents questions. If you wanted to practice more, there are more regents questions given in your handout, and the answer key is also posted on your Google Classroom website. Please solve those questions and find me during office hours if you need help. Thank you.